Alright, so the first page is trig equations, your first learning target. On number 1, we got cosine x equals square root of 3 over 2. Is your trig function by itself? Now you don't have these, I just made these up. Alright, so your cosine is square root of 3 over 2. Are we dealing with x or y? X. Where would that be positive at? Quads what? 1 and 4. What family are you dealing with? Pi over 6. So it's pi over 6 and 11 pi over 6. Number 2, I have cosecant squared minus 2 equals 0. What's the first thing I would do on that? Move the what over? 2. Cosecant squared theta equals 2. Now, I'm going to take the what? Square root. When you take the square root of something, it's what? Plus or minus. Okay, now, do I want to work with cosecant? No, I'm going to work with which one? Sine. So I'm going to change it to sine. In order to change it to sine, I got to flip this. So now I'm going to rationalize my denominator. What family am I dealing with? And I want the positive and negative. Just leave it on my desk, hon. That's fine. I want the positive and negative, so that's all the family members. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Alright, number 3. What will be the first thing you do there, Derek? You're going to move that negative 4, yep. So I got 3 tangent squared x equals 1. What's the next thing I'm going to do, Jackson? Very good. Tangent squared x equals 1/3. Parker, what's the next thing I'm going to do? Very good. When you take the square root, what you got to do, Harrison? Plus or minus. Do you know the square root of 1? Do we know the square root of 3? No. Oh. Alright, so tan x equals plus or minus 1 over square root of 3. I got to do what, guys? What family has a tangent square root of 3 over 3? So you want all the family members because you want plus or minus. That's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Alright, number 4. Can I combine a sine x, tangent x, and a negative sine x? No, so what must I do? Take a sine x out. I'm going to set sine x equal to 0. Where's my sine values equal to 0? Okay, I got to establish my thing up here. Let's say, will that include 2 pi? No. Alright, where's sine x equal to 0? 0 and pi. Tangent of x minus 1 equals 0. Tangent of x equals 1. Where's my tangent equal to 1 at? I mean, what family? It's positive, so what quadrants am I dealing with? Very good. So that's going to be pi over 4 and 5 pi over 4. Alright, number 5. What does that look like? Quadratic. What type? Easy or bust them up? So I'm going to let u equal what? Sine theta. I'm going to rewrite that as 2u squared minus u minus 1 equals 0. It's got to multiply to give you negative 2, add to give you negative 1. Bust them up. 2u squared minus 2u plus u minus 1. You got 1 just like everyone I'm doing right here. Take a 2u out. U minus 1. Take a positive 1 out. U minus 1. So I have u minus 1 and 2u plus 1. I'm going to substitute sine back in there. So I'm going to have sine of theta minus 1 equals 0 and 2 sine of theta plus 1 equals 0. Sine of theta equals 1. Where does sine equal 1 at? Pi over 2. Okay, move this over. 2 sine of theta equals negative 1. Divide by 2. Sine theta equals negative 1/2. What family are we dealing with there? Pi over 6 in what quadrants? 3 and 4. 7 pi over 6 and 11 pi over 6. So those two and this one. Alright. This is u substitution as well. U squared minus u minus 2 equals 0. So that's going to be u minus 2, u plus 1. I'm going to substitute cosine back into there. Move this over. Is there anywhere cosine value equals 2? No. I'm going to remind everybody to be off their phones. I'm not doing this for my entertainment.
At this time, may I please have all senior superlatives to the rotunda? Senior superlatives, please make your way to the rotunda for pictures.
Okay. I'm going to move this over. It becomes a negative 1. Cosine theta equals negative 1. Where's my cosine value equal negative 1? Pi. Very good. That's my only answer. Are there any questions on that first learning target, solving trig equations? Okay. First 11 on your test deals with that. Next 4 deals with the sum and difference formulas. Learning target 2. Okay, we use this when we do not know the exact values. And look at the top of my paper how I did that. I did 30, 45, 60, and 90. Do you see how I put the degrees, the radius, and then found the common denominator? Isn't there a quick reference for you? You need to do that tomorrow, okay? I need to know cosine of 15. I could use 45 minus 30 or 60 minus 30, 60 minus 45, either one. So I'm going to say cosine of 15 equals cosine of 45 minus 30. I'm going to go to my sum and difference formula right.
Teachers, may I have your attention, students? All girls going on the engineering trip should make your way to the bus area at this time. All girls on the engineering trip.
So this is this minus this. I'm going to use this format.
Thank you.
So I got cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Cosine of 45 is square root of 2 over 2. What's cosine of 30? What's cosine of 30? Root 3 over 2. I get root 6 over 4 plus root 2 over 4. That gives me root 6 plus root 2 over 4. Are there any questions on that? Alright, 7 pi over 12, sine. I'm going to add the 3 and the 4 pi. So this will be equal sine of pi over 4 plus pi over 3. In this particular case, does order matter? No, because addition is commutative. That's subtraction, it does. Okay, so this is sine and addition. Sine and addition, I'm going to use that format there. Sine of pi over 4 times the cosine of pi over 3 plus, what is it? Cosine of the first one. Okay, I'm running out of room, sorry. And then sine of the second one. Square root of 2 over 4 plus square root of 6 over 4. Now on these, are we working backwards? Yes. Okay, so it starts with sine. There's a minus. So I go over here. Sine, there's a minus. That tells you what to do. What you're going to do with the two values? Subtract. So I got pi over 3 minus pi over 12. I'm going to find a common denominator. That gives me 3 pi over 12, which reduces to pi over 4. So I'm going to find the sine of pi over 4, which is square root of 2 over 2. This starts with tangent. There's a plus in the numerator. Plus in the numerator. I'm going to add those two. 48 plus 12 is 60. What's the tangent of 60? Square root of 3. Are we good on that? Okay. When I say find me the sine of 2 theta or tangent of 2 theta, what formulas am I using? Double angle. Okay. So it says given cosine theta equals negative 3/5 in quad 2. Draw a picture. Cosine is adjacent over hypotenuse. Your hypotenuse is always what? Positive. Okay, in the quadrant 2, your y value will be what? Okay, you know that's a Pythagorean triple, 3, 4, and 5. Okay, I got my cosine value. I need to find my sine value and my tangent value. My sine will be 4/5. My tangent will be 4 over 3, negative 4/3. Now, do I have enough information to find these values? Yes. Sine of 2 theta equals all of that. Negative 24 over 25. Tangent 2 theta. Following this one right here. 2 times your tangent over 1 minus your tangent squared. And then you just divide that out. I'm running out of room, but do y'all know how to do that? Are we good with that? Alright, so today we're going to look at our homework. You have number 54. Okay, let's talk about 54. 54, you got to be careful on 54. It says the tangent of theta equals negative square root of 3, and it's in quad 2. I know tangents defined by opposite over adjacent, but you see, Mr. Chester, I just have one single number there. Can't you write that over 1 and make that a fraction? Yes, that's what you have to do in this case. Now, opposite over adjacent. Now you say, Mr. Chester, why do you have a positive root 3 in your picture when it's negative? You've got to keep this in mind. This is why this is very tricky sometimes. You've got to think about it. You've got to look at the picture. In your picture, in quad 2, your y value is going to be what in quad 2? Positive. Isn't that your y component right there? You said, Mr. Chester, so your x is negative, but that says negative. Isn't a positive divided by negative make the whole thing negative? So even though it looks like it's negative square root of 3, that part's actually positive and your x component's negative 1. Does that make sense? Okay, you've got to think about that. Your hypotenuse is 2. So I got my tangent value. I did my sine and cosine right there. What now?
How is the hypotenuse 2?
Okay. Negative 1 squared is 1. I square root of 3 is 3. 1 plus 3 is 4. Square root of 4 is 2. Now I did my sine 2 theta, my cosine 2 theta. Sine 2 theta gave me 2 times root 3 times negative 1 is negative 2 root 3 over 4. Simplify the 2's. Here, plug that in. Negative 1 squared, negative 1 half squared is 1/4. 1 half times 1 half. Square root of 3 squared is 3. 2 squared is 4. That gives me negative 2/4, which is negative 1 half. Tangent 2 theta. 2 times tangent theta over 1 minus tangent squared. 2 times negative root 3 over 1 minus negative root 3 squared. On top, that gives me negative 2 root 3. Now be careful here. You've got to do what's inside the parentheses. A negative squared is a positive. It's going to be a positive 3, but you've got to bring that negative. 1 minus 3 is negative 2. Cancel those out. That's root 3. Are there any other questions on this? How to find your double angles? Okay?
Is there going to be one of those long tangent sum and difference formula ones in the test?
One. That's only one. But it's not that long. I was kind of nice. One of those where you could choose between pi over 3 and not do the long pi over 6 one. If you remember, you could go the other way. Alright, 55. Okay, we're going to use the half angle here. Cosine of pi over 12. The first thing I'm going to do is say pi over 12 times 2. That gives me 2 pi over 12, which I'm dealing with pi over 6. Okay, cosine, I'm going to use this one right here. Now, you look at the original problem. Pi over 12 be in what quadrant? 1. So I'm going to be using the positive square root. So 1 plus cosine of pi over 6. I get 1 plus root 3 over 2 divided by 2. Do I need to find a common denominator in this numerator? Yes, you're so smart by now that you should be able to do that in your head. That's 2 plus root 3 over 2 divided by 2. And you also probably can be smart enough to know what you said the numerator divided by 2, you can do that here. It's going to flip the 2, isn't it? So in the denominator, there's going to be a 4 there. Now, does that make sense? If you cannot do that in the head, work everything out on the side. I can determine the square root of 4. So that's how I arrived at my answer with the 2 on bottom and the square root on top, and that is my answer. Alright, number 56, sine of 65.5. I'm going to start off by times that by 2 and get 135. 135 is on the unit circle, so you can work with that. You're going to have a value you're going to be able to work with. So I'm going to put that in there. It's sine, so I'm going to use this. Okay, go back to it. Sine of 67.5. 67.5 is in quadrant 1. The sign will be positive. That's why you see the positive roots. Okay, cosine of 135 is negative square root of 2 over 2 because 135 is in quadrant 2. Wait. Yes, cosine, yeah. So it'll be negative. So that's going to be a double negative there. So I got 1 plus square root of 2 over 2. I find a common denominator. Then I divide by 2 inside the radical, which flips that 2 and makes this a 4. Because you're multiplying by 1/2. I take the square root, there's 2, leave the square root in the numerator, and that's my answer. Are there any questions on the half angle ones? Alright. On 59, 60, and 61, it's working backwards because they're informed of a formula. Now, it starts with 2 sine. I look here. That starts with 2 sine, isn't it? That's a what formula? Double angle. That means you're going to double it. I told you yesterday, change this to 75, change this to cosine. So I'm going to double 75. So 75 doubled is 150. So sine of 150, which is 1/2. This one has a cosine squared in it and starts with 2. So I know to put cosine down and double it. I times pi over 8 by 2. I get 2 pi over 8, which reduces to pi over 4. Cosine of pi over 4 is square root of 2 over 2. Number 61, the format 1 minus 2 sine squared is right there. I know to put cosine down. I double pi over 12, which is 2 pi over 12, which reduces to pi over 6. Cosine of pi over 6 is root 3 over 2. Okay? Are we good on our homework?
Can you show number 56?
56? Yes. On number 9 and 10, you would see sine 2 theta and cosine 2 theta. That means that's the only answer for that. Sounds off page 19 and 20. Yeah, it's putting on the data file here. After you're done, I want you to complete 57, 58, 62 on the homework page. We're going to do those 3 problems. Your homework tonight, just study, study, study.